We'll discuss very important strategies to solve force related problems in vectors. We'll use two different methods to solve, and also a visual explanation will be given to figure out which force should have been bigger or greater. Let us enjoy the journey of learning. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, I am going to share with you a very important test question based on vectors. We're talking about resultant forces. The question is shared by my student who wants to understand different approaches to solve such problems. And that's a very good request. Not only we are going to discuss this solution in two different ways, but we are also going to understand the situation in a deeper way. You will soon realize what I mean by saying so. Okay, so let's read the question first. Two tugs pull a barge with two ropes at 45 degrees and 30 degrees to the horizontal direction of the motion. This statement is indeed complicated. Let's try to read it once again and understand what the question is really asking for. So we have two tugs which are pulling a barge with two different tow ropes. One is at 45 degrees, the other one is at 30 degrees to the horizontal direction. Make sense? If the resultant force is 600 newtons in the direction of the motion, determine magnitude of each vector component. So it's a very complicated statements are there, right? So that's why we need to spend some time before we answer, right? So let me just represent the situation on a coordinate plane. So it seems that the direction is horizontal, correct? Perfect. And two tugs are pulling it, one in 45 degrees. So let me draw a 45 degrees angle here, right? So this is a one of them, right? 45 degrees. The resultant is along the horizontal. So when I say that the resultant direction of the motion is along the horizontal, that means, let's say this is force 1, right? That means the y component of this, let me just show you this part. This is the component which is y component of force 1, correct? You need to find vector components, right? So, and the horizontal component is this one, which is, let me write this as F1x. Since the motion is only horizontal, nothing along the vertical, the two vertical components should cancel, right? So keep that in mind. So the other force, which is at 30 degrees, for that we have the same y component in the opposite direction. Makes sense, right? Kind of some. Well, and the angle here is 30 degrees. So let me make this angle 30 degrees. Do you understand? So this is fairly accurate representation of the given question. Makes sense, right? So these two forces are equal and opposite, and therefore the motion is along the horizontal line. So that's one thing. Now, second thing is we are given the resultant, which is 600 newtons. So 600 newtons is along the horizontal. That is what it is. To complete this diagram, let me draw the parallelogram, right? So drawing a line parallel to this and parallel to the other one. we make our parallelogram, right? How do we solve for the forces F2 and F1 and their components? So this is F2x. We could use one of the two methods. One is, of course, we can split a force in their xy directions as required and find each one of them. The other one is that we could use trigonometry of cosine sine law in this case, right? Since we know the angles, we can also use sine law. So we'll have two different approaches. One will work with the components of force, and the other will use sine law. Make sense? So these are the two approaches which we are going to apply. Now look here. As far as the magnitude is concerned, do you see the force F2, which is along 30 degrees, you can see magnitude of force is actually greater than the magnitude of force 1, which is at 45 degrees. Sometimes that is the question, as I have asked in my channel, right? So, if we have these forces acting at the angles as shown, then the force acting at smaller angle will be bigger in such situation where the y components cancel away. And also you realize that f1y magnitude is equal to the magnitude of f2y. Correct? And of course, f1x is the magnitude of f1x along the horizontal is cosine component of f1. And the horizontal component of the other force is also cosine component of 30. Okay, so magnitude of 2 cos 30. Make sense? So that is what we have. Now let's write down the solution. I hope the concept is clear, right? So with that, I hope the concept is absolutely clear. You can actually pause the video and answer this question. Adopt both the approaches. Those of you who want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are getting admission to the best universities with scholarships, right? So they are the first ones to get admissions in the university. So some of them have already got the confirmation. Great. Congratulations to them. Okay, so now let's begin the solution. So what we have done here is that is the diagram which we are looking into. I'll make slightly smaller one here. So we have this component 45 degrees. The other one, we know that this is same, right? So 30 degrees. And we can make a parallelogram showing the resultant along the x-axis, resultant being 600 newtons, right? The angles 45 and 30 degrees. So first thing, what is this angle? Well, clearly this angle is 180 minus 45 plus 30, correct? Great. So this angle is 180 minus 45 degrees plus 30 degrees. Great. So this angle is equal to 105 degrees. So we know this angle. Now let's apply the first approach, which is we know that this force we're calling F1 and the other force is F2. So we are saying that F1 magnitude of sine 45 degrees is equal to F2 magnitude of sine 30 degrees. So that means the vertical components, right? Perfect. So when we say sine 45, that means We are saying that F1 magnitude is, well, 1 over square root 2, which is F2 magnitude. Right? You can use special triangles. Sine 30, as you know, is half times half. So we have this relation, and from here we can always say that F1 is equal to F2 times square root 2 over 2, right? Correct. So that is how the forces are linked. So we get one from the horizontal first equation. Let's call this as equation 1. The second one is that the resultant is along the horizontal. That means the horizontal components add up to 600. Right? So we have magnitude of F1, the horizontal component being cos 45 degrees plus F2 sine cos of 30 degrees, correct, equals to 600. Perfect. So you can always write F1 as F2 square root 2 over 2. So I'm substituting this value here, square root 2 over 2. And cos of 45, this is times F2, right? Cos of 45 is 1 over square root 2 plus F2 magnitude, and cos of 30 is square root 3 over 2, right? And all this is 600. So now we have an equation in only F2, correct? So, um, well, we can cancel this, right? Square root 2 is square root 2. Multiply by 2, right? So we get what? So magnitude of F2 plus square root 3 times magnitude of F2 is equal to 1200, correct? So that gives us the value of F2, right? So we have F2 magnitude times 1 plus square root 3 equals to 1200, right? Or F2 magnitude is 1200 divided by 1 plus square root 3, correct? So we can find this value, correct? So 1200 divided by, within brackets, 1 plus square root 3. 349.3, 439.2. Right, 2, 3. So we get 439.2 as F2, right? So now we can find the value of F1, right? Okay, great. So the value of F1 is what? So from here we get F1 magnitude is square root 2 over 2 of 439.2. Correct? So we'll divide this by square root 2. And we get 310.5 newtons. 5.8, so we could actually round it to 5.8, so we can round it to 6, right? So we can actually rewrite this as the major forces, right? We'll find the components later. So we got the force F1 magnitude as 310.6 newtons, and the magnitude of F2 is 439.2 newtons. So as predicted, you see the magnitude of F2 is more than that of F1, correct? So of course now you can find the components also. So F1y is equal to F2y, correct? Equals to, you could use any one of them, 310.6 times sine of 45. So use any one of them. So f1 sine 45, f1 is 310.6 times sine of 45 is 1 over square root. Is that clear to you? So we get this component. So we'll multiply, or rather divide this by square root 2. So we get 219.6. So the magnitudes of y components are this one, right? The magnitude for the x components are different. So we'll multiply each. So for f1 x, it'd be 310.6 times cos of 45, which is 1 over square root 2, which is again same as 219.6 as expected because the angle is 45, correct? Right. And as far as f2x is concerned, it will be 439.2 times sine or cos of 30, and cos of 30 is square root 3 over 2, right? So let's figure this out. So 439.2 times square root 3, right, divided by 2. 380.35, so I'm rounding it to 4 newtons. Makes sense. So this is our first method where we use the components and found the solution. So I hope you have understood this, right? You can go through it once again if there are any difficulties. Now let's look into the second solution. So once again, let me sketch the diagram right there. So 45 degrees, 30 degrees, right? Okay. We know the angles 45 and 30. We know this is 600, and that angle is 105. Perfect. The forces are F1 and F2. Now we can use sine law, right? Because we have a combination. We know this angle, correct? And what we really need to find is the force F1 and the force F2, correct? We know the side, which is 600 opposite to 105. As the diagram is concerned, so this side is F2, right? And this side is F1. Makes sense? Okay, great. So if you look into the diagram itself, in that case, you know, this is the resultant, which is 600, which is opposite 105. So we could say magnitude of F2 over sine of 45 is equal to 600 over sine of 105. So the magnitude of F2 is equal to 600 times sine 45 over sine 105, correct? So let's calculate 600 into sine of 45 degrees divided by sine of 105 degrees. So we get our answer, which is 439.23. So I'm writing this newtons. Is that clear to you? That's what we got earlier also. So I hope this is absolutely clear, right? Now let's find the other force. Now other force F1 we are trying to find. So F1 is across 30 degrees. You see the magnitude, so sine 30. This angle is again 105. So we have 600 over sine of 105, correct? And therefore, the magnitude of F1 is 600 times sine 30 over sine of 105 degrees, correct? So we have 600 times sine of 30 degrees this time, divide by sine 105, and we get 310.58. You see that? So we got both the forces. And as we did earlier, these are same numbers, correct? Since we need to actually find each vector component, so let us find the components also from this, right? So F2y component, we are looking into F2y means this one, correct? So which is equal to 439.2, and vertical component is sine of angle 30 degrees, correct? F2x is 439.2 and sine of 45 degrees upwards. Correct? You can calculate these values as we did earlier. Similarly, find F1y, which is this component. Same as F2y, you will realize. So it is 310.6 sine of 45 degrees, and F1x is equal to 310.6 sine of 30 degrees, correct? And you will also realize, check, that F1x plus F2x is indeed equal to 600. Is that clear to you? So we did all the calculations right here, right? So you can approximate and check this. So if you add these two values, correct, it is indeed 600, right? So that is the check. So I hope with this you have understood clearly how do we solve such questions. The two methods have been shown. Follow the one which you like. Feel free to like and subscribe my videos. If you want to share, please do share. And if you want to contribute, please send an email on globalmathinstitute@gmail.com. Thanks for your time and all the best.